Okay, cool. So that's recording. So yeah, as Norman says, I'm Wes Little from Control Point, and what I'm going to go through today is more based around CPD than around us trying to sell Control Point. There's aspects of it that obviously include what Control Point does, because that's how we get access to the data. But effectively, I'm just going to run through some very simple lessons we've learned and a bit of input from some of the people around how to make a good electrofusion joint that lasts for as long as humanly practicable. So really, from depending on not knowing anybody's knowledge, there's a number of ways of joining pipe, but in particular with plastic pipes, it's primarily going to be butt fusion, electrofusion, or flange or mechanical. And really what I wanted to run through was some of the common causes of electrofusion failure and some simple tests to eliminate them. Talk a bit about pressure testing. I've got a few slides from Antire in relation to that. And then really the main bit at the end is really what we're going to propose to do differently, which is more related to the use of AI in order to help inspections. So the images that you can see on the right-hand side of the slide deck, those are photographs from clients who are using our system that have sent them in. The way that our system works is it integrates with the Electrofusion box. It's up to each client to decide how they work and what standards they follow, but these are real life examples. So the top image there, you can see a reducer on a gas pipe. It's not restrained, so it hasn't been clamped. The reason probably for that is the width of the excavation. The second picture down is a temporary cap and end cap on a gas pipe. And again, it's unclamped, but also there is no evidence that it's in the correct distance. Can everybody hear me? Can't hear.
Yes.
Yes.
Yeah. I think it's fine.
Somebody just said they couldn't hear me. Right. Okay. Cool. So unfortunately, the squeeze off is too close. Now lots of people say it's the Control Point standard. It's not. We effectively follow the manufacturers, and there's a number of fittings manufacturers, I'm sure, who've joined this to see what we're going to say. This isn't about singling out the right or wrong fittings. This is about using them in the way that they were designed and tested to do so. So for those who are unsure, it should be, depending on your client, but usually it's recommended it's 2.5 to 3 diameters of the pipe before you apply the squeeze off. And then the second and final picture just shows that sometimes people go to the best endeavors to try and have a clamping position, but you can see that clamp's not doing anything because it's not actually in contact with the pipe. So these are the type of things, common mistakes we see, which are effectively quite easily resolved. In terms of us, this is really very briefly. The key point to take from that, you can read the rest, is we are not a pipe manufacturer or fitting supplier. Many moons ago, we were part of the Fusion group, but for many years now, we've been independent, so since about 2010, 2011, and really our focus is purely on electrofusion or butt fusion, joining the pipes and the quality. We don't sell equipment, we don't hire, etc. Our main premise is our inspection services, our EUSR training services, and our lab services. And those are the kind of areas where we generate the data from. So whatever I tell you today is based around facts as opposed to just pure opinion, where we've been engaged with doing testing for UCWI, testing for suppliers and other partners. So one of the things I did when I talked to Bentley's a couple of weeks ago was look at the electrofusion quality assurance, and people always talk about what QA is. So I'll let you read those bullet points. But one of the misconceptions that we have is that people think that a QA system's around achieving perfection, and it's not. It's an efficient means of producing the quality that the market requires, and that's whether the quality for your network that you're installing for, or whether that's for whatever the standard states. Again, it's got to be fit for use, and it's got to conform to some requirements. All pipe and fittings are manufactured to very stringent controls, ISO standards, and as such, the products have been designed to work in very challenging environments. But unfortunately, the human factor does mean that some of these fittings then subsequently fail. And it's fair to say you can't claim you have a quality control system without first having a quality assurance and a quality management system in place. Unfortunately, and these are two extremes, I grant that, but unfortunately when joints fail, the impact can be quite significant. In that, you can see on the left-hand picture, unfortunately, that is a explosion from the States, Harlem gas. And ultimately, what occurred there was a polyethylene riser. The joint subsequently failed, caused gas improperty, and then as a result of that, unfortunately, 8 fatalities were caused and hundreds of lives were impacted. On the right-hand side, something a bit more closer to home. Again, it was nearly a decade ago, but unfortunately, a butt fusion joint beneath a large electricity pylon damaged or became damaged or failed. As a result of that, 18,000 homes went off gas for a significant period of time. I think it was round about very late December, probably the 23rd, 24th, I think it was. And in good old-fashioned British tradition, as we have now in the COVID situation, people were cooking Christmas dinners on barbecues and doing the like to try and keep going. But that said, avoidable based on the investigations done. So what I'm going to talk about is electrofusion jointing and butt fusion jointing. So the two key differences for those who are unsure is butt fusion basically involves taking 2 pieces of pipe, heating a very hot plate up between them, and then bringing them together, and with a correct amount of force and pressure, cause those 2 to join together. And effectively what you're doing is you're creating a melt zone on either end of the pipe, and then you're causing those 2 joints to join, and you'll always generate some form of bead on either the inside and on the outside. Electrofusion is sometimes perceived as the easier solution certainly for the smaller diameters, so 180 and below, but it's common to see we're doing some work with Welsh Water now, and they're using 560 mm electrofusion. And really what electrofusion is, it involves the use of a coupler or fitting in order to join those 2 pieces of pipe together. And essentially, good electrofusion practice requires you to do 3 very basic fundamental things. You've got to clamp the pipe. So as a fitting heats up, basically what happens is you apply energy into that fitting. That fitting then starts to melt. That melt zone is then designed to cause the pipe it's close to melt, and the 2 to become 1 piece of pipe. So the weld becomes as strong as, if not stronger than, the original pipe itself. That melt gets to roughly kind of temperatures in excess of 200 degrees and can generate a few bars worth of polymer pressure. So the reason it needs to be clamped is to prevent the pipe from moving during the welding process, because all fittings are designed with cold zones and flow zones to make sure that you get a good bond. Scraping, most of the pipe, you'll have seen it, either travels around on the back of lorries, sits in people's yards, sits at the side of the road. Mostly they've got dirt and debris on them, but in effect, what we're trying to remove when we do scraping is the removal of the oxidized layer that's on the outside. And it's not a lot that needs to be removed. 0.2 to 0.4 of a mil is what most manufacturers recommend. And there's 2 methods. In the gas, if you work in the gas industry, you've probably seen people with a tool that looks like a Stanley blade on its side, which is a hand scraper. And basically all they do is they then scrape the material off in longitudinal methods. In the water, it's pretty much common practice to do that with a mechanical scraper. And for simplicity, a mechanical scraper is a bit like a large pencil sharpener. And basically what you do is you attach it to the pipe and you wind it round. It has a little bung that fits inside the pipe, usually adjustable to a variety of diameters. But in the water, they've mandated that. We haven't seen so much of that in the gas, but we can see that coming. The benefit with a mechanical scraper is you do effectively get a circumferential scrape at a given distance all the way around. With a hand scraper, you are relying on the strength of the individual doing the scraping. So on a warm day, we have noticed that co-extruded pipe will scrape or shave very easily if you apply a lot of force to it. And obviously that is the key impact, is the human factor side of it. And contamination. Joints should be clean. They're supplied to you quite carefully by fittings manufacturers in lovely bags. What you shouldn't be doing is ripping that bag up and then dropping the fitting in the dirt and debris on the site before you're fitting it. The idea is it comes in a very clean, clinical environment. Contamination takes a number of forms. People have different schools of thoughts about which is the worst contamination. So if you say mud that you would expect to see in a normal excavation, right through to dust on a day like today. So it's been quite warm for a couple of weeks. If anybody is working today with the wind that we've got, there's a chance that that dust and debris will blow down the site. And a lot of the failures we simulate, it's as easy for us to use talcum powder as a simulant as it is to use mud and dirt. And I'll show you a video on that shortly. The final type of contamination that a lot of people seem to get concerned around is raindrops or water. The water can track inside a fitting during the welding process, and all that creates is effectively gaps in the weld, so little spots where the water has been evaporated where you won't have a full weld. If any of those line up, you could then end up with a leak path, and that's obviously something that we're trying to avoid. So, simple rule of thumb, clamp it, scrape it, keep it clean. That should give you a good opportunity to get a good joint. In terms of where that data comes from, when we look at data, when we look at testing, so this isn't just the joints that we physically see or inspect, these are joints that are sent back to us and lots of white papers that have been written. Really, these are the primary causes for electrofusion joint failure. And some of the images are just showing that joints can follow a full weld process. So you type a time into your box, the box will weld, you take your leads off, and you think you've welded the joint, but actually all that's happened is the polymers got very hot, melted, but not melted the pipe that it's in contact with, and we call these brittle failures. In terms of very simple layman's sense, you should be able to pull the two pieces of pipe together, and if you have a ductile failure, it pulls apart a bit like chewing gum, and if you have a brittle failure, it'll probably snap like a Kit Kat. And those are really the things that we're trying to avoid. You may think you've successfully welded it, but then in a year, 2-3 years' time, another utility could jump in your excavation and find that actually you'd only generated a brittle weld. In terms of electrofusion joint failure, this is the bit that really kind of always interests myself, and there's a YouTube link if you go and watch it, and hopefully the video will show, is there is a test that is performed, and it doesn't look like the most glamorous of tests. It's a crush test in accordance with the British standard, and what you should be able to do is find that the pipe will withstand an amount of crush force, and hopefully the video will play. So this is a video that we've made around joint contamination. It's available on our website. What we've made is two pipes, and one pipe with a joint, and we've effectively quartered it. That pipe's passed a 100 millibar pressure test, so we know that it's a good joint from that perspective. And what we've actually done is we've mechanically scraped it, which is why you can see the circumferential lines. And then basically what we've done is we've applied an amount of talcum powder during the process. So this is an internationally recognized test. You squeeze the two pieces of pipe together. This applies a tensile force to the sample. And then what you're basically doing is bringing the two pieces of pipe together. And what should happen is the joint and the pipe should remain as one. And then what you do is a decohesive test, is you usually use a screwdriver or a device to lever it off. And no more than 30% of that can pull away for it to consider to be a pass. This is the same joint, same pressure method. And you can see there straight away, as soon as force has been applied, you're starting to see what we would call a brittle failure. You can see it's now separated, a little bit of leverage, and unfortunately it comes clean off. What you can see there is it is completely debonded from the pipe. What they are is heat scorch marks. And those scorch marks means that heat was applied and it went through its weld cycle, because we know the other side was fine, but the contaminant prevented the joint from being made. This is similar when you say to people, if you walk on a very hot beach, the top of the surface can be very, very hot indeed, and it's difficult to walk on. You dig a few inches below the top surface and it's cold, and that's effectively what happens is the contamination becomes a barrier from preventing the weld to take place. The molten pool doesn't occur, and therefore the pipe doesn't melt and join or bond with the fitting, and therefore you end up with a very weak or brittle joint. Again, these are photographs that we have had received. Now, they're always interesting. People get a little bit upset sometimes with me and say that we're bashing people. This isn't what it's about. You know, these guys are working in, as you can see, very challenging conditions. We're not expecting people to work in a lab style condition, but ultimately there's got to be a training aspect for that. And one of the things that we're really passionate about is not just pointing out that things aren't to the required standard. And this isn't a control point standard. This is the WIS, it's the water industry standard, or the gas industry standard. And that guy's done his best endeavours to make that joint. But maybe he doesn't understand how easily a joint can fail when it's contaminated, when it's not been scraped correctly, and when it's not clamped. In the water sector, some of this isn't picked up. Joints that do fail, we'll cover these stats later, joints can fail during commissioning. They're often replaced. No one's ever the wiser. And there is a real lack of data available about how many joints genuinely fail through poor workmanship that aren't then subsequently replaced. Again, this is an example from a gas client. Again, a best endeavours approach to some extent, because you've got a Electrofusion equal T on two pieces of, I think it's 180mm pipe. The trouble with coil, and anyone who's on this who's a pipe specialist will know, it's very difficult to join two pieces of coil together because naturally there is a radius or a bend in it. What they've tried to do is to take that away by using a digger bucket to hold it down. Because of how they've prepped it, they've already pre-scraped the outlet on the T, and you can see that's quite heavily contaminated now. What they'll do next is apply a fitting to that and then join another piece of pipe onto it. There's nothing to say that that operative won't then subsequently properly clean that outlet, but I think the challenge that they've got is there's no ground sheet in place, and there's nothing really to help them make a good joint. Again, the second picture, this was a joint that was done late at night. You know, one thing we must never forget is, you know, the guys are on site are under extreme pressure sometimes to be able to get customers and houses back on gas in a sensible operating timeline. This was a joint that was made, again, unfortunately, it's not 3 diameters away from the reducer. The reducer is unrestrained, so there's a chance it will move. This fitting was actually fused 3 times before it was able to pass its weld cycle. We didn't get to recover the joint ourselves. It was disposed of straight away. But one of the things that we would have expected to see is that the copper wires inside that caused the melt would have probably moved to the point where they then affected the resistance. And at some point, the welding box saw too much resistance and wouldn't allow the fitting to weld. But again, you would hope that, as with water and with gas, people wouldn't be making these mistakes deliberately because nobody wants to do a terrible job. Very brief, everyone's seen these safety triangles. All we would suggest is that if you have 1 or 2 examples of a leak, or you've had a couple of close calls or near misses, there's a probability that there's a behaviours piece below that where they may not have the right tools, the right training, or the right understanding of what does or doesn't make a good joint. In the gas, it's much more challenging. Gas and property can obviously lead to fatalities. But in the water, the impact is still as high. If you have a water joint fail, you can lose whole towns off water for significant periods of time, and especially at the moment where we need much more controls in place. Welsh Water are using us to look at their electrofusion and butt fusion processes to make sure that everything's done in accordance with the standards, so that they don't run the risk of people having no water to wash their hands. We're often perceived as the people in that picture, unfortunately. I can't recall a site when I've been to site and a operative is super pleased to be submitting their work to us for us to inspect. But what we're trying to produce or provide is a service that allows the reduction in cost and the reduction in risk and uncertainty for the asset owners. They know that that joint has been installed on a given time to the manufacturer's recommended methods of clamping, scraping, cleanliness, and weld time. And really, that's what we're trying to do, is increase, through events like this really, the skills, the quality, the safety and the longevity. In theory, according to the research, albeit we have a 50-year life on polyethylene pipes, there's a school of thought that believes that on a water pipe, for certain, you would be looking at a pipe that's laid today. There's no reason that it shouldn't last at least 200 years. I think it's actually 234 years. This is a joint that some of you may have seen if you've ever been to Control Point. It often gets a few odd looks. We have it in the building. This is a joint from a very old system. So they'd sent us the data. It was the time when we only had one photograph sent through. And what it did is we've inspected that in accordance with what the client has asked us to do. It wasn't clamped. It didn't have hatch markings, and albeit hatch markings don't affect joint quality, what they do make it easy for people to see when you're looking at an excavation if it has or hasn't been scraped correctly. We couldn't see if it had been peeled properly or scraped, and it was quite dirty, generally around the fitting. The supervisor was alerted about that joint, and as is the way, he took a decision to bury that joint. Happy with the risk, and that's all we're flagging. We're not saying it's a good or bad joint. We're just identifying risk that's agreed with the client, and they decided that they would bury that joint. Unfortunately, that is the joint 4 months after it was installed, and it was removed. What occurred was a leak path, they believe, came out of the coupler. Unfortunately, that leak path used a very nice new aggregate, and that became a tunneling or a shot blast, and then effectively the pipeline then completely failed. We believe, or we're led to believe, that the failure was probably in the region, with all things considered, about £125,000. In theory, I think if they'd resolved that and removed it, as much as it would have been challenging and time-consuming, would have been probably nearer to the £3,000 mark, which is an industry standard calculation for the cost of when joints fail to mobilise teams and take back out to site. So, pressure tests. Whenever I go and do presentations or whether we deliver training, lots of people always say, I've never had a joint fail, it's always passed the pressure test. I won't read the full dialogue out, I'm sure you're all capable of reading that yourselves, but ultimately for us, it's a bit like an MOT. It is not a long-term indicator of quality. This is only identifiable through looking at how the joint was prepared in the first place. And we work with organisations like WIS, who have evidence to show that there are an average of 13 bursts per 100 kilometres of fittings that are under 1 year old, which is a startling number. That trend doesn't really change a great deal up to probably year 10. So we are burying pipes now, and it's well publicised through WWT and Utility Week that water companies in particular admitting that they have got infrastructure that they've buried that's less than 10 years old has already failed. And that shouldn't be the case. This is a stat from Tony Kitchen of Antire. So in theory, according to industry data, 3.2 billion litres of water is lost every single day, and 8 out of the 18 water firms are missing the leakage targets. Now, obviously, all of that is not related to new pipelines, but it is a percentage of that. And from Antire's data, they're basically saying that 13% of failures were as a result of leakage. So that means during the commissioning of a brand new piece of pipe, 13% of the time, those joints will fail. And they are a mixture of both mechanical and electrofusion. And we believe that all of those can be resolved. So it's a worrying statistic that we are laying pipe today that's going to last at least 100 years, if not longer, that isn't being laid correctly or was as anticipated, and therefore would possibly fail and result to additional costs, but also customer dissatisfaction. Where we do provide an inspection service, we find that for any joint that we say is non-conformant to the standard, and usually if we pick the high-risk ones, clamping, alignment, or scraping, or contamination, 94 of those, or 94% of those joints out of 100, so 94 out of every 100 joints, will fail an industry test. So if you're using our system and we flag it to you as being non-conformant for a major reason, there's a 94% chance that that will not pass the destructive test. And it's not just us that are saying this. There's the HSE have been quite vocal. It's a similar slide. I'm sure you've all seen this before, but this was a NEAG presentation in London in February when we weren't all doing social distancing. And you can see there that the the HSE are saying that of the 7 joints that they had, 4 of those were attributed to poor installation, which should have been resolved. As I said, what we don't do is we don't make Electrofusion boxes. We only provide the software in order to harvest data from the Electrofusion boxes. And there's a variety of boxes that you can use and a variety of hire partners you can obtain those boxes from. Some of those hire partners have their own methods of collecting data, And if you haven't looked at the benefit of collecting data, I'd strongly advise you see, if you are welding, whether that's butt fusion or electrofusion or flange, what technologies are available in order to capture really valuable data today that will be even more valuable in 10 to 15 years' time when you want to know what products you've buried at what location. In terms of our app, this is probably the only bit I'm going to go through. We connect via Bluetooth to an electrofusion box. That, as I say, allows us to take weld data, so the weld parameters from the box, the weather, the GPS location from your phone, and then we require operatives to submit a series of photographs in a prescribed manner, so one from the top, one from the left, one from the right, to show how they've prepared that joint prior to installation. And then we basically provide a risk-based guidance for the client. And depending on what the client wants, they can determine how stringent they are. So people will talk about confidence indexes, where they're looking for total quality, or we talk about conformant, non-conformant, which is basically making sure that they comply with the standards. That data is uploaded from the box after every single weld. But one of the main things that we're looking to do is to harvest as much data as possible, even if you're not looking to have the joint or all of the joints inspected. So what we are able to do is, as this picture shows, is we have a dashboard system that shows the power of the data. Luckily, all of the fittings come with barcodes, and what we're able to do is to scan those barcodes and automatically program into the weld box the exact weld time based on the temperature. Lots of people, when we talk to them, don't realise that on most fittings bags, there is a little chart and table that shows you how much time you should knock off when it's a warm day and how much time you should add on if it's a cold day. By using the smart scan methodology, and these are something that we've integrated, but for years you've been able to get the devices that plug into the weld boxes, you can ensure that you capture the weld time correctly. Often an electrofusion box will remember the previous weld time. And what we sometimes see when people start using our system is they will weld a joint for 55 seconds, like a top tee, move on to do the reducer, forget to change the time, and then in order to weld it correctly, they'll pull the leads off. Now, there's nothing wrong with that if you're not running it through the system, but it's unlikely that if the weld time's 33 seconds, that you're exactly going to remember to pull it off on exactly 33 seconds. What we can take, because we know the GPS location, we know the date, the time, the type of phone that was used, we can tell you the weather condition, we can allow you to add extra data. And that's really one of the things that I think we should all think a bit more about in this situation we're in at the moment. Where it isn't feasible to go to site, you can have the data come to you live and see how many joints have been made, whether they comply with your standards, and then add additional data to it. So the last two slides, really mindful of time. Sorry?
Seems to be anyways. I see rang me there earlier on.
Ah, so someone's talking. Anyway, so final two slides. So what we're doing differently, and this is really where my passion comes for this, is we're moving into an advent of AI. And there's a big difference between machine learning and artificial intelligence. I don't think I can turn this guy off.
Sorry, can whoever's speaking, can they switch the mic off, please?
I've done it, Norman, it's fine. Machine learning, people talk about artificial intelligence. You've seen these Google cars driving up and down the streets, automated vehicles, etc. It's kind of a balance. Machine learning and AI are used together effectively. And what we're saying is most of our services that we do provide to our clients are after the event. We have photographs of how they prepared the weld, but we only receive the data when the weld is completed. And what we're trying to push for is, people have talked about blockchain and big data where you could run very quick searches. There's a good example from Asda. They used to take them something like, I think it was about 7 days to work out where a punnet of mango came from, the original source. They can now do that in about 5 seconds by linking all of the data sets together. And what we were looking for was to change the face of quality assurance for electrofusion, certainly. So what we've done is we spent the last 2 years developing a platform that allows us to be able to recognize shapes and features automatically from a photograph. So we've got a little robot, for want of a better word, or a robot brain that lives in the cloud that allows, when it receives photographs, to look at combinations of clamps. Now, The reason we've been able to do this is because we have probably one of the world's largest repositories for weld data, in that we've been able to capture something in the region of about 10 million data points on our database over the last decade. And we can analyze the photographs. These aren't staged in a workshop. These are actually real life photographs. And we've taught the AI bot to recognize the difference using heat maps to work out where clamps are present. That was what we managed to do probably over a year ago when we presented that at Lines Lair. Where we are now is the AI can now easily detect whether or not something has been contaminated, whether or not it has been mechanically scraped, or whether or not there are water particles on it. Now, people often say to us the water is because they're working so hard and it's drops of sweat that are bouncing off the joint. But invariably, when we check the weld data, we can see from the weather data that it was raining at the time. So possibly didn't have a tent up. But that shows you the power of AI. Now, the way that we think this will work, and most of our clients are pushing for this, is we would envisage that the AI is effectively a very quick check. So you take your photographs, which is how it works at the moment. You submit them as if you were going to ask the box to weld. The box won't weld at this point until it's done its AI. And what it does do is it allows you to be able to check within 15 seconds that the three basics have been addressed: clamping, scraping, cleanliness. It checks that, and if it doesn't detect any errors, it will then allow the box to be able to start welding. If it does detect errors, it gives the operator an opportunity to either disagree with what it thinks it's found, or allow them to rectify the problem. We do see on a lot of occasions where people are sharing clamps on sites and sometimes won't go and get them out, or they won't, or they don't believe they've got the room to get it in due to other infrastructure. If you want to, using the AI, you can then lock that box and prevent it from undertaking a weld. And really, this gets us totally round to which we started with, which was our right first time approach. And that's really all we're trying to do, is show that there are very simple tools and techniques blended with technology now and training that means that any joint that's made today should last at least 200 years. And that is the end of the presentation. So I was slightly over by 3 minutes, so apologies for that. I will go back to the beginning if it lets me. So Norman, over to you in case there's any questions.
Well, just looking on the chat, the first is a comment about, I would suggest pulling leads off a live welding fitting is a very unsafe practice. I don't know if you've any comment on that.
Yeah, of course. I mean, of course it is. What I'm saying is that if you've got a weld box and it's got 55 seconds on it, and you basically you start welding, you've noticed that the time has gone too far. We have seen it where operatives will remove the leads from the fitting during the weld process. What that does is it causes the box to stop immediately welding as soon as it loses connectivity with the fitting. That's not just to do with the app, that's purely down to the safety features of the Electrofusion box. So it won't deliver any more energy once it doesn't see that it's got the resistance. So effectively the Fusion box is like a large electronic circuit. If you pull the pin off, then it won't weld. But we do see people doing that. If you're using a control point system, it will notify you that somebody's done that. You could just press the stop switch on the box. But unfortunately, we have seen very many things done. Lots of people do that, or they could even just turn the generator off. We see very many different techniques.
And then the next question there on the chat was, is the tent or shelter compulsory or recommended?
We, as a quality assurance company, would always say, yes, if you can use a tent or a welding brolly, we would certainly recommend using it. In probably the butt fusion area, it's very, very, very unusual, even though it's not compulsory, highly unusual for people to do butt fusion activities without the use of a tent. The machine normally goes inside it and they weld away inside it. We would say yes, but it is down to the client. We obviously can't tell from the photographs whether there is a tent assembled, but whenever we do the training, we always recommend the use of tents or appropriate cover from wind and dust, etc., as well as a ground sheet to protect the fitting from ingress of water or debris from the base of the excavation.
And the next question, I don't know if you can see these, Les, but Wes, but the next question is, can you use the AI in a similar fashion for hydrostatic and pneumatic testing?
Yeah, potentially. To be fair, we were talking to, I was talking to Tony Kitchen this morning because we were unable to join, which is why he had me put the 2 slides in. But effectively, we're seeing a lot of people now looking for AI. Now, what Tony and I agreed on was AI is a bit like an automated process at the moment, in that there's certain things you can do as long as you can tell it what the parameters are, on the basis that people need to accept that where we are at these early stages, there's probably still a requirement for some human intervention, but it can look to address some of the basics. What we can do with, you know, the likes of Antire and other people is, because it's an open source data set, you could link your weld data to your pressure test data to show that you've done the pressure test in accordance with the requirements. The same as you can link your bead data. So we have a method of testing destructively on site beads and linking that data straight into the weld machine as well. So there's lots of stuff we can do on that.
Yeah. Just again on the chat, Julia True has just posted a link for people for guidance on butt fusion.
Yeah, and I've agreed with Ian McCluskey to do a separate session for iGEM on all things butt fusion, because butt fusion is a slightly different area and often one where people get a little bit concerned about butt fusion. So we said we'd run another CPD on butt fusion, and on that one we're going to get, because it's not just about control point as such, we're going to get the likes of peak pipe, probably radius, and some of the machine manufacturers to come on and explain with butt fusion how it's very much about people, product, and plant.
Right. The next question we've got is, can you elaborate on why mechanical scraping has not been adopted by gas companies?
Unfortunately, I can't. I don't know why they don't use it. It is not without its challenges. Obviously, mechanical scraping, there are devices for mechanically scraping where top tees are, but generally speaking, it is always done by hand scraping. Mechanical scrapers, a lot of the times people find them quite difficult to use initially to get set up, and they prefer to use the hand scraping method. I think it's just the way that the gas industry is. We've seen a few, the likes of Cadent on the Balfour Beatty GDSP contract, are moving towards mechanical scraping, but I suppose there's no right or wrong answer to that. It's whatever your engineering codes and practices demand that you do. On the water, it does say in the WIS standard that it should be mechanically scraped.
Okay. Oh, right, sorry, now we've got another question. Have there been any fusion failures with a joint that's going through control point and passed? If so, what was the root cause of the failure?
If we've passed it, i.e. it is a conformant joint, normally we have varying scales of conformant joints, and because we're so confident because of the data we've got, we will guarantee joints. So if a joint is fully conformant to all of the standards, we would guarantee that joint for £5,000 for 10 years. And of those joints which we have, not one of those joints in the last 10 years have failed, because the system has been built around using partnerships with fittings manufacturers, testing where next over used to exist, etc., to really drill into the detail of how you can identify photographically what is a good or bad joint. So no, we don't see joints fail that go through control point. The only time you may see a failure is if there is an issue with the with something that we haven't been able to see. So maybe the fusion time was incorrect, but we would normally pick that up. Not all people use the smart scan. Sometimes it is down to the operative to enter the smart at the time.
Right. So we've got another further question.
Okay.
Wes, you're doing well here.
Right.
Radius Profuse is a peeled pipe and the major pipe used in Severn Trent Water mains renewal work. What is oxidization time period recommended prior to welding once peeled?
I wouldn't like to take a guess. I'm not sure who's on the call, if there's anybody from Radius. Dave McDonald. Dave, if I unmute you, do you know? Dave?
Wes?
Yeah?
Yeah, it's Mark Hunter here.
All right, great, cool.
All right.
Hi, Norman.
Hi, Mark.
This is a continuous process. So, like scraping a pipe or peeling the pipe, it must be considered to be one continuous process. And there isn't a magical period of time, such as 1 minute, 2 minutes, 5 minutes. It should be continuous. And the purpose of that is to minimize any dirt or debris buildup on the pipe, which is precisely the discussion that you're mentioning here. Oxidation is something which takes place at a much longer rate. So this would be more concerned about dirt and debris buildup on the pipe. So should be one continuous process. That's our recommendation. And as Wes says, in dry and wet periods, the use of welding shelters is preferred.
I think the other thing, whilst you're on as well, Mark, is that sometimes with Profuse, there's the other one, the barrier pipe as well. And often what we do see is the manufacturer has gone to great efforts to pick the right tooling for preparation. And sometimes we do see where people haven't used the correct mechanical scrapers to remove it and the foil layer. Isn't that right? I think, Mark?
Yeah. Wes, if I could just go back to one of the earlier points raised regarding the gas industry and the use of hand scrapers and rods.
Yeah, of course, yeah.
Yeah, Profuse pipe is used, or skinned pipes are used a lot in the gas industry, and this could be one of the reasons why hand scraping is used more for the smaller sizes, where Profuse is used for the larger sizes. So yeah. The Profuse pipe is one where you peel the skin from the pipe. And if peeled correctly and the joint undertaken correctly, then there should not be a requirement to scrape the pipe unless it has been contaminated after the peeling process.
And we do see for joints we get submitted, lots of people will peel the pipe and then scrape it as well. But you see scraping a lot more prevalent even in the water on the top tee outlets, where you've got very little material to be able to do a scrape, but that doesn't mean to say that scrapers or mechanical scrapers don't exist for that size.
We've won another question. Perhaps we should make this the final one.
Okay.
If a pipe has been correctly scraped and is cleaned, is there a need to use fusion wipes? There's an interesting one.
So I will give you our advice on this. We do not recommend the use of weld wipes for any real reason. You could use them prior to scraping to remove contaminant if you were concerned about the transfer of contaminant during the welding process. We don't typically recommend the use of weld wipes purely because they can sometimes leave a contaminated layer on the pipe when it's fused. So no, I think once you've made the pipe clean and you've scraped it, you're effectively down to as best virgin material as you can be, and you should then be able to do the joint. So we wouldn't recommend the use of fusion wipes. You've no idea how old they are, how much alcohol's in them at that stage. So generally speaking, we're not a big fan or encourager of the use of weld wipes. I'm happy for other people to disagree, but that's our view.
Well, from a Radius Systems perspective, we'd fully agree with you, Wes, that the final pipe surface preparation method should be the scraping method, and thereafter there should not be a need to wipe a joint. Wiping a joint can smear dirt across the welding surfaces and also leave residue on those surfaces, which could detract from a good quality joint. So there should not be a need, but we do appreciate that some clients do have a preference for the use of wipes, but from Radius Systems perspective, it's not our preference.
To that last question on there, I'll just do that one. If the pipe has been correctly scraped and as is clean, that's the same bit. Yeah, I mean, sometimes where we do see people using well wipes, and again, this is down to people's interpretation, and I'm not a fittings manufacturer, but again, we would discourage it. We do see where fitting bags have been damaged. Some people will use a weld wipe to clean the internals of a fitting. Again, really, you know, you would probably argue that if the fitting was small enough, you would probably dispose of that fitting because it could be very contaminated. You know, we don't recommend the use of fittings that have been out of the bags because they can get oxidized. But equally so, if you've dropped a fitting in the dirt, you've probably as well as taking a new fitting than you are trying to clean it up, I suppose. Would you agree with that as well, Mark?
Yeah, yeah. If the fitting's been, if the bag's been opened and there's dirt on the fitting, we would recommend that you choose another fitting.
Great.
Great.
No more questions.
Right, everybody. Well, thank you for all participating. I'd like to thank on your behalf Wes for a really thought-provoking presentation, and we can see how good it was by the number of questions we had. So thank you very much, Wes. I'd like to remind you that we as the Pipeline Industry Guild are running a series of webinars. We're running both technical webinars as well as social and softer subject webinars. And so I would recommend that you keep looking at the Guild website for details of our program. We're trying to run maybe 1 or 2 of these a week. Thank you again for participating. I hope you've enjoyed this webinar, and we look forward to, let's say, better times when we can all meet together and perhaps have a more open debate. So,
yeah, and if anybody's got any questions, feel free to contact me. You know, as I say, of course, I work for Control Point, but you know, we're more than happy to kind of spread the word about quality assurance. It's a big thing, certainly for the water and gas industry, that whatever we do today needs to last for a considerable period of time.
yeah, and I'd also like to thank Mark also for giving
Yeah,
some
great. Thank
answers.
you for that.
That was really good for him to come on and do that. So
Yeah, thanks, Mark. Appreciate that.